Hello friends, in the previous lecture we have seen that the concept of inverse of a matrix. Now we intend to discuss the application of matrices for solving system of linear equations. For this, first we learn to convert the given system of linear equations in the form of matrix equation. Now for that we consider two linear equations. 2x plus 3y is equal to 5 and x minus 4y is equal to 9. Then these equations can be written as below or can be shown as below in the matrix form. This is the first matrix 2 by 1 matrix, and here it is the 2 by 1 matrix. 2x plus 3y, x minus 4y, 5, 9. After that, using the definition of multiplication of matrices, we consider the above equation as 2, 3, 1 minus 4, xy, 5, 9 separate. If we multiply these two matrices, we get as above. Now if we denote by left hand side matrix by A, the variable matrix by X, capital X, and constant matrix by B, we get here capital A, X, and B. Then we get the equation Ax is equal to B, where A is the matrix column matrix of variables. Sorry, X is the matrix column matrix of variable capital X. A is the matrix of coefficient of variables, and B is the column matrix of constants. Before that, here note that capital A is the 2 by 2 matrix, and capital X is the 2 by 1 matrix, and capital B is the 2 by 1 matrix. Similarly, if there are three linear equations in three variables, then as shown above, they can be expressed as similar Ax is equal to B. And then find the respective orders of the matrices capital A, X, B in case of the three equations in three variables. Then this matrix equation Ax is equal to B in both cases, two variables or three variables, can be used to find the values of the variables x, y in two variables or in the three variables x, y, z, as the case may be. Now for this applications, there are two methods for these applications, namely first one, method of inversion and method of reduction. Now today we shall discuss only the first method of inversion, and from the name of this method we can guess here we have to find the inverse of a matrix. Now this method we can explain by an example here. Now let us take an example. Solve the equations 2x plus 5y is equal to 1 and 3x plus 2y is equal to 7 by the method of inversion. This is the two variable example solution. Using the given equations, we get the corresponding matrix equation. That means the matrix form of the given system of linear equations can be written as first of all coefficient matrix 2, 5, 3, 2, and second it is variable x, y, and last one constant matrix 1, 7. That means Ax is equal to B, where A is the matrix 2, 5, 3, 2, capital X is the xy, capital B is the 1, 7. Now if we pre-multiply by A inverse to this equation, we get here A inverse into A, X, is equal to A inverse into B. By associative law, we can separate there. Then and we get inverse and the itself matrix multiplication is identity matrix I into X, and we get here X is equal to A inverse B. And after that, if we find the inverse of matrix A, after that then multiply A inverse and B, and we get here capital X, that means XY, and on equating the both the matrices we get the variables X and Y. This is the method. Now we will find here the inverse of matrix A. Now as A is equal to 2 5 3 2, determinant of A is equal to 2 into 2 4 minus 15, that means minus 11. And adjoint of A, we know that adjoint of 2 by 2 matrix is change the diagonal elements and changes the sign of the non-diagonal elements. Here the diagonal elements are the same 2 2, and the sign changes between 3 by minus 3 minus 5. This is the adjoint of matrix A. It is very simple, that's why we won't be calculating here. Now A inverse is equal to 1 upon determinant of A into adjoint of A. Here it is the determinant and its adjoint of A. Therefore A inverse is equal to minus 1 upon 11 2 minus 5 minus 3 2. Now from an equation 1 we get here X is equal to A inverse B. Here it is the A inverse and here it is the B, constant matrix. Now we multiply these two matrices. We get here first row first column 2 into 2 minus 5 into 7 minus 35, that means 2 minus 35. And here second it is minus 3 into 1 minus 3 plus 14. That means here minus 1 upon 11 into minus 33 upon 11. Now we divide 11 both the elements, and we get also multiply minus 1 on into the matrix. We get here 3 minus 1 here, and therefore capital X is equal to 3 minus 1, that means XY is equal to 3 minus 1. Hence by equality of matrices we get X is equal to 3 and Y is equal to minus 1 here. Now next example, here it is the 3 variables example. Also the required matrix equation is, first one is a coefficient matrix 1 minus 1 1, 2 1 minus 3 and 1 1 1. Here it is. And the second matrix is variable X Y Z, and last one is constant matrix. Then that is X is equal to B, where A is this matrix, X is the variable matrix, and B is the constant matrix. Now on pre-multiplying A inverse in the similar way by last example, and we get here X is equal to A inverse B. Now we will find here A inverse. First of all, we shall find A inverse using adjoint method. That's why we can find here first of all cofactors of all the elements of the matrix A. Therefore A11 is equal to, that is here formula for cofactor of the first element A11, minus 1 raised to Aij is equal to minus 1 raised to I plus j into minor of that element Mij. And we get we know that how to find the minor of an element Aij. On deleting first row first column, we get the minor of an element determinant. That's why A11 is equal to minus 1 raised to 1 plus 1 into M11, that is equal to minus 1 square into 1 minus 3 1 1, that means 1 plus 3 is equal to 4. Similarly second element A12, on deleting first row first column second column in the matrix A, we get the determinant 2 minus 3 1 1, and we get here minus 1 cube is equal to minus 1, minus into 2 plus 3, 2 minus of minus 3, 2 plus 3 is equal to minus 5. Similarly A13, minus 1 raised to 1 plus 3 M13, we get here 2 minus 1 1. A21, minus 1 minus 1, minus of minus 1 minus 1, that means minus of minus 2, that means 2. Similarly A22, minus 1 raised to 2 plus 2 M22, that is equal to minus 1 raised to 4 1 1, that means 0. A23, minus 1 raised to 2 plus 3 into M23, that is equal to minus 2. Now A31 minus 1 raised to 3 plus 1 is equal into minor of the element M31. On deleting third row first column, we get the determinant here minus 1 1 1 3, and minus 1 raised to 4 is equal to plus 1 and then minus 1 into minus 3, 3 minus 1, that means 2. A32. On deleting third row second column, we get the determinant 1 1 2 3, that means minus 3 minus 2 minus 5, and minus 1 raised to 5 minus, that's why we get here 5. A33 is equal to minus 1 raised to 3 plus 3 into M33. M33 is the minor of that element. After on deleting third row third column, we get the determinant 1 minus 1 2 1, and we get here 1 plus 2, that is equal to 3. Now we get here all cofactors of all the elements of the matrix A. That's why cofactor matrix is equal to A11 is equal to A12, A13, A21, A22, A23, A31, A32, A33 is equal to, this is the cofactor matrix, and we know that the adjoint of matrix A is equal to transpose of that cofactor matrix, and we get here, look at here, 4 5 4 minus 5 1, 4 5 minus 1, here it is column, here it is the row, here it is the column, 2 5 3, here it is the row, and here is the column. This is the adjoint of matrix A. Also determinant of A is equal to 10. You can check it here. And we know that the inverse formula for A inverse 1 upon determinant of A into adjoint of A. That's why 1 upon 10 into the matrix 4 2 2 minus 5 0 5 1 minus 2 3. Now from an equation 1, what is the equation 1? X is equal to A inverse B. That's why this is the A inverse and this is the constant matrix B. On multiplying these two matrices, we get here 1 upon 10. First row, first column, that means 4 into 4 16, 2 into 0 0, 2 into 2 4, that means 16 plus 4, that means 20. Here it is the minus 5 into 4 minus 20, and 5 into 2 second element 0, that's why it is again 0. 5 into 2 10, that means minus 20 plus 10, that means minus 10. 4 plus 6, that means 10. Now on dividing 10 in the matrix A, we get here 2 minus 1 1, that means capital X is equal to 2 minus 1 1, that means capital X Y Z is equal to 2 minus 1 1, and therefore hence by equality of matrices we get X is equal to 2 minus 1 1. This is the required answer. Thank you.